Okay, this is the solution to our alpha beta program or problem. So we have the equation that our change in length is equal to our original length times our change in temperature times alpha. And we assumed that we had a cube that was 1 meter by 1 meter by 1 meter. Okay, so the volume of this is a cubic meter. Okay, length times width times height. So our volume is a cubic meter. That is the original volume. So we're going to find, and then we assumed that we had a change in temperature of 10 degrees. We just made these assumptions. And we assumed that we had an alpha of 10 times 10 to the minus 6 degrees Celsius, per degree Celsius. So we're going to find our change in length. So our change in length is our original length, 1 meter, times our change in temperature, 10 degrees, times our 10 times 10 to the minus 6 per degree Celsius. So our change in length comes out to 0.0001. That's our change in length. So on our cube here, each of our sides got 0.001 meters longer. So the length of the sides of our cube now is our change in length plus 1, our original length. So the new length is 1.0001 meters. So then we need to find our new volume. Our new volume will go length times width times height. And so we take 1.001, and we cube it. And we find that we get 1.0003 cubic meters. Okay, so that's our new volume. And then in our second equation, we want to use change in volume is equal to our original volume times our change in temperature times beta, or our volumetric coefficient of expansion. So if our new volume is 1 times 1.0003 and our original volume was 1, our change in volume is now 0.0003 cubic meters. We subtracted those two volumes to find the change in the volume. Our original volume is 1. Our change in temperature is 10 degrees. I guess I wrote that in wrong the first time. This should be, oops, we won't undo all that. This should be change in temperature. And then we're solving for beta. Well, when you solve for beta, you find out that beta is 3 times 10 to the minus 5 per degree Celsius, which is the same thing as 30 times 10 to the minus 6 per degree Celsius, which, hey, is 3 times that original alpha that we started with. Okay, so that's what we set out to prove, that this, our beta, is 3 times our alpha. Now you could try it out again with a different change in temperature, different lengths, and you'll find you get the same ratio. You should get the same beta again as 3 times 10 to the minus 6. Even if you changed your alpha, you should still find that this relationship holds true.